Hello, in today's video, we are going to be talking about LeChatelier's principle. So what this has to do with is when a system's at equilibrium, so the rate of our forward reaction would be equal to the rate of the reverse and the amounts of everything would have come to a constant level if we change something. So if we change the concentration of one of the substances, the pressure or volume for the gases, or if we change the temperature, then the reaction will have to re-establish equilibrium at a new point. So basically the reaction will have to either go forward or do the reverse reaction in order to re-achieve equilibrium. So that's what we are going to be talking about today. All right, so the most simplistic way to look at this is to look at a reaction. So let's say we have this reaction down here. So the system is already at equilibrium. So rate of the forward reaction is equal to the rate of the reverse reaction. If I increase something, what I want to do is I want to pick the reaction, either the forward or the reverse, that would use that substance up. Or in a simpler way, we literally move away from the substance that was increased. So down here in this example, if I increase the amount of NO, so again, I'm at equilibrium and then I add NO. My choice is to either do the forward reaction or the reverse reaction. So the forward reaction would occur because I have too much NO, so the forward reaction would help to consume that. Or again, you take the more simplistic approach, and if I have too much NO, I would point your arrow away from it. You do the forward reaction because you would move away from it. All right, so then again, we're back to equilibrium. Everything is all good. And then we open up the container and increase the amount of NO2. So NO2 is over here. So I have too much NO2, so I would want to move away from NO2. So I would do the reverse reaction to consume some of the excess NO2. Then next we have add more O2. So again, we're back to equilibrium. Everything's good. And then we increase the amount of O2. So in order to get back to equilibrium, the forward reaction would occur because that would use up some of the excess O2. Or again, you move away from the thing that you have too much of. Now, if I have decreased something, then I need to produce it back. So you would want to move towards it. So if I've decreased the NO2 in here, then I would need to produce it back. So I would have to do the forward reaction or move towards that. All right, when we change the temperature, you will treat it basically the same as we just did on the previous slide. So if we increase temperature, then that would favor the endothermic reaction because we would want to use up some of the excess heat. Or you have too much heat, so you shift away from the heat. And if we've decreased temperature, that will favor the exothermic reaction because we have to make back that lost heat. Or if you don't have enough heat, you have to shift towards it. All right, so in this example, our system is at equilibrium, and then we have increased the temperature. So we have too much heat, so the reverse reaction would happen because that would use up the excess heat. So the reverse reaction would occur at a faster rate until we got back to equilibrium. And last one, we have this reaction here, and this time we have decreased heat. So now we don't have enough heat. So our problem is not enough heat. So we would have to move towards heat or do the reverse reaction.